Hey guys, and welcome back. So in the previous nugget, we happened to mention that the kernel was modular, meaning that it relied on modules. So let's now dig in and discuss a little bit more about this subject. Now, one thing to say that off the bat is that generally speaking, you're not going to have to worry about loading particular modules with the kernel. This is going to be an automatic process. However, there may be times where you want to manually intervene and take particular control of a particular module, i.e. to load that module or to remove that module. And as such, it is important that we do have a strong understanding of what that process would actually look like. So let's dive in and discuss some things we have to know then, shall we? So in the previous nugget, I happened to mention that if we go into the lib directory and then go into the modules directory, within here, we're going to have a folder for all of our kernels. Simply put, each kernel has its own subdirectory. So this kernel here has its own subdirectory, whereas this one here has another one with its modules, so on and so forth. And we learned the command we can use to identify the kernel running on our system as the uname command with the -r flag. So try to remember that command. So let's go into the folder or the subdirectory of the kernel we are currently using. And if we do an ls, and in fact, let me long list this, you're actually going to see we have a directory called kernel right here. If I go into this directory and I list again, we can see a whole bunch of subdirectories relating to modules for particular features such as drivers, network modules, so on and so forth. So if we wanted to see modules related to the file system, we would go into the fs directory for file system, and we do an ls. We have some modules right here which end in .ko, and as we can see here, we actually have further directories relating to our file system. So I could go into, say for example, ntfs, do an ls, and we can see the ntfs file system module for the kernel right here, again with that .ko extension. Now, the reason why you want to know the location of these particular modules is that if you want to load in a particular module, certain tools will require you to specify the module's particular location, so you have to be able to identify it. Now, one thing to say is that when we want to copy a particular module, there is a very specific command that we have to be aware of, and that is called the depmod command. Let me just clear my screen. That will be depmod, so depmod. Now, what this command actually does, it ultimately looks in to the lib modules directory, which we just saw, and then the directory for that particular kernel number. So that would be, if I actually move back a few, let me see the directory here, looks in lib modules and then the subdirectory for the particular kernel. And then it's going to ultimately grab all of the modules within the kernel directory within this folder. So everything within here, and it is going to generate what is called a modules.dep file. Now, this file happens to be really quite important. We do want to be remembering this one for sure. And what it does, it basically gives us a list of all the kernel modules and those module dependencies. A dependency meaning that a module may actually rely on another module to operate. So pretty much everything we actually need, i.e. all the modules and the modules which rely upon those modules, will actually be specified within this modules.dep file that has been generated. Now, one thing I really want to highlight with respect to the depmod command is that this command is only going to execute with respect to the current kernel in play. So you know how I do have other kernels on my system. Again, if I go back, we do an ls, we can see these 3 different kernel options. The only one I happen to be running right now is 5.13.028, so it's only going to act within this directory right here and probe for the modules within this directory and its subsequent subdirectories. Now, when a module happens to be loaded into memory, we actually have a bunch of commands that we can do to ultimately check and manage these modules. The first one we can do is the ls mod command. This is going to allow us to list, i.e. ls, the modules. So check this out. If I happen to run this command and I say ls mod, we're going to get a whole bunch of output. Now if I scroll up to the very top here, we can actually see the module name on the left hand side right here, and the size of that particular module, as well as any dependencies, i.e. what is this actually used by. So we can see here, BTRFS actually uses the RAID 6 PQ module, whereas the HFS module, no additional modules are actually reliant upon this module. And I suppose I should actually mention is that the size here we're actually looking at, this is in bytes, just for clarity there. Now, if you want to be able to remove or unload a particular module, you're going to have to make sure that this particular module has the value 0 in the third column. That means that it's not being used by something else, therefore it can be successfully removed. Whereas if we try to remove this module right here, we can see it's been used by VBox Video, therefore we're not going to be able to do such a thing. Now if I want to be able to manually remove a particular module, I can use the rm mod command, and again, these commands are quite appropriately named. RM, typically in Linux, is for remove, such as rm a particular file, and we want to remove a particular module, so rm mod. The name itself is quite descriptive once you actually understand the Linux jargon. So if I examine some of the output right here, take for example this one right here, PATA ACPI. What I can do is actually remove this then, okay? So first thing I will do is I will say ls mod. That gives us the listing. And what I'm going to do is I will actually grep for PATA, so we can clearly see it's loaded. But if I happen to say rm mod and then say PATA ACPI, and notice one thing I should have actually pointed out, when we are making these kernel changes, this is going to require super user privileges. So what I'll actually do is I will just become the root user, type in the old passwords, there we go. So I'm now the root user. Let's try this command again. So ls mod, grep PATA, it's still loaded. If I now say rm mod and then give the name of the module, PATA ACPI, if I hit enter, this module will now be removed. So if I actually check again, notice the output of the ls mod command. We actually don't have any output for PATA ACPI. It has been successfully removed. Now, if I want to actually insert a particular module, we have a command called insmod. So insmod, insert module. Again, really quite easy to remember once you understand the jargon. The difference here is that if I just happen to say insmod, like PATA ACPI, notice it's saying there is no such file or directory. We have to be able to identify whereabouts this particular module is. So what I can do though, is I can clear the screen, and I can try to clear the screen by not mashing the keypad, and I'll use our trusty find command. We learned about this command in the LPIC1 examination. So what I will do here is I will search for absolutely everything, which we can see here, but I'll stop this right now. And instead, I will actually grep for what I'm looking for. So I'll grep for PATA ACPI. Notice we actually see the output here. We need to pick the one which corresponds to our particular kernel. So I'll say uname-r. So it will be in this one right here, 5.13.028 folder. And I can use this with the insmod command. So I can say insmod, and I will just copy this location right here, paste it in. Again, with the .ko extension, this is what we have for our modules for the kernel. If I now hit enter, this should now reload this module back into the kernel. And again, if I happen to run my ls mod command and hit enter, notice this module has been successfully loaded once again. And in fact, if I just run the ls mod command on itself, this module should actually be at the very top of the output. You see that? Right here, because it was the last one loaded in. So if you want to load in a particular module manually, you can use the insmod command. This is kind of deemed the more difficult way because again, we have to manually identify the particular location of the module itself. But we do have a more modern approach, and in my opinion, a much better approach. And we can do this using the mod probe command. This is deemed the much easier and simpler way to handle such a task. So previously we were removing and re-adding the pata ACPI module. We can do the same thing using mod probe. So what I will do is I'll say mod probe and I will say -r. This is for removing, and now I just give the name of this particular module, and that should it be now removed. If I do an ls mod, it will no longer be there. Again, if I grep for pata, it is no longer there. Now this time when I want to reload this module using the mod probe command, I don't have to specify an absolute path. I can just say mod probe pata ACPI and hit enter, and if I check my ls mod, notice it has been loaded in once again. Now why is it the mod probe command is able to almost magically and automatically handle this process? Is that mod probe is getting this information from whereabouts? Well, it was the information we talked about when we run the dep mod command. What does that command actually generate? It generates a modules.deb file, in which case this ultimately tells us all of our modules and our module dependencies. So mod probe is looking into this file, and just by simply giving the module name, it can solve all the other issues itself directly. So way easier than having to manually provide full paths yourself. But like I say, you are way more likely to never actually have to need to use these tools, because the kernel will handle the loading and removing of these modules on the fly automatically. But in the event that maybe a particular module is causing an error, maybe you have to manually intervene and remove and maybe reload that module, or perhaps you just want to free up additional memory by proactively going in and removing modules which have been automatically loaded, which you have deemed unnecessary for the operation of your system. In which case, being able to understand these tools are really going to be advantageous to you as you manage your Linux system. Okay doc, so that is us for our introduction into the modules of the kernel, and I hope this has been informative for you, and I'd like to thank you for viewing.